Hey everybody, welcome to another homework help video with me, Mr. Parsons. If you're watching this video the week I posted it, I apologize for not doing it faster. I had to move, and when I moved, I didn't have internet access for a few days, and uh, can you imagine that in 2020, right? As you can see, I have a different background behind me because I'm in a different place for now. So anyways, that aside, let's do some of this week's stuff. This week, the topic is the quadratic formula. So I really wanted to bring it all together on this help video and kind of describe something to you before we start doing the quadratic formula like actual assignment, and I'd like to show it to you on the side here. And I'm sure you're thinking, "Oh geez, here he goes." But listen, it'll be good for you, I promise. We saw this last few weeks different ways to solve equations, and we've been solving equations since the beginning of the school year. For example, you've been solving stuff like this, right? 2x plus 3 equals 7. The goal is you want to find out what value of x makes this true, which in this case the answer is 2 because, you subtract from both sides, you get this stuff right here, you divide by 2, and there you go. The value 2 makes it true, right? But what happened when we had problems that were a little bit more complicated, especially ones that had squared terms in it? For example, what if it's x minus 3 squared um, equals 7 or something like that, right? How do you solve that? Well, there's two answers that make that true, as we learned, and there's different ways you approach them, and there's different kinds of problems. So this is one type of problem. This is the first type of problem we saw, which was the ones where you would be best suited by rooting both sides, and then you'd get plus minus root 7. You'd add 3, and you'd get two answers: x equals 3 plus the square root of 7, and x equals 3 minus the square root of 7. So that's one way to solve it. If it has like a just x squared and no other x's anywhere else, or x and something else in a parenthesis squared, you can easily solve that one, right? Then we learned, what do you do when you have something like this: x squared minus 7x plus 12 equals 0. Maybe you're solving something like that. Well, it has an extra x in there, which makes it not able to be done like the last thing I showed you, but you can, I'm skipping some steps here, factor it, x minus 4 and x minus 3. So this factors into that stuff I just wrote there, and using the zero product property tells me there's two answers here, is 4 and 3. So that's another way you can solve it, right? We also saw some stuff where we graphed and moved things around, and there was a way to solve it by graphing. And on the most recent stuff we did, we completed the square, which was a pretty difficult process because the problem was it wasn't factorable like the thing I just showed you. So it was like, what do you do when you can't factor it? So like x squared minus 4x plus, put something that doesn't work, 7. Nothing multiplies to make 7, but adds up to -4, right? So then what we ended up having to do was we had to move 7 to the other side, and then take the 4, and then complete the square, and then we could factor, and then we could answer some stuff, right? All right, whew. So here's the thing, though, and this is where we're bringing it all together here. Completing the square is not a very fun process, but it does work every time. Even if you could have factored it, or even if you could have just square rooted it. Oh, that'd be gross if you could have just square rooted it, just square root it. But like, you can complete the square and always solve it. But isn't completing the square kind of like a meh process? It takes a lot of steps, right? Well, some smart, intrepid person back in ye olden days uh, figured this out. You can always get the answer. The answer is whatever x equals, right? What does x equal? Well, they took a generic formula with ax squared. So they took ax squared plus bx plus c equals 0, and they said, I'm going to solve this for x by completing this square. And you think, okay, that's kind of weird. How do you do that? Because there's no numbers in it. Well, it can be done. And what it turns into is x equals negative b plus minus, a plus minus sign, kind of like from earlier. And inside this giant root is b squared minus 4ac. That's not a very good looking 4. I'm going to redo that one. 4ac. And it's all over, everything's divided by 2a. And you're like, okay, that's a thing, right? What that is that's the answer to some completed square for every problem ever. So what I'm saying is you never have to complete the square on any problem. This is called the quadratic formula. It answers the question of what are the solutions, or what are the roots, or what are the zeros for a formula in this form, standard form, where all the a and b and c stuff is on one side and the other side equals 0. So our goal on today's assignment is we're going to put it like that, ax squared plus bx plus c equals 0, and then we're just going to take the a, b, and c's and ploop them into the formula there, and it'll be easy peasy. All right. All right, so let's begin this. Let's begin this thing. So problem number 1 says, let me write it down, 2x squared plus 7x equals 6. Now, on each of these problems, the formula requires that everything be on one side, and it needs to equal 0. That's why I wrote ax squared plus bx plus c. It all needs to be together, and it needs to equal 0. So in this situation, I need to move 6 to be with the other stuff. So 2x squared plus 7x minus 6 equals 0. Now, if I was a person doing an assignment and I didn't know it was going to be use the quadratic formula, I would definitely try to figure out if I could factor it first. For example, 2 times negative 6 is negative 12. Is there anything that multiplies to make negative 12 yet adds up to make 7? If the answer to that is yes, then I could factor it, and I could probably get my answers, and it'll be a little bit cleaner than plug it into the formula. But even if you could factor it, you could still plug it into the formula. So I'm going to use the formula anyways, obviously. I'm just saying it might be good to check. Okay, so here's the thing. I'm going to write the formula again without so much extra junk. I keep tapping the little writing pad here each time I write. All right, so here's the formula. Negative b plus or minus b squared minus 4ac all over 2a. So what you need to do is do this. Identify what's a. So in my problem, a is 2. B is 7, and C is negative 6. That's super important that it includes the sign. So the positives be positive, and something with a negative in front of it needs to be negative. Okay, now I'm going to plug it into the formula. So the formula says negative b, so that means the opposite of b. So my b was 7, so I will write negative 7. Inside here, I write b squared. Now you can find out what it is and plug it in right away. For example, I could write 7 squared as 49, but I'm going to be a little slow here and write 7 squared minus 4 times a. In my case, a is 2. C is negative 6. Keep the sign. And everything goes all over 2 times a. So 2 times 2 in this problem. Okay? So what that turns into is negative 7 plus or minus the square root of 49. Let me fix that 4. It's gross. 49. That's what 7 squared was. And then 4 times 2 times 6 is 48. In this case, it's positive 48. And this is all divided by 4. And just one more simplification is negative 7. Let me make that better. I don't know what's up with my writing pad today. It's kind of being touchy here. 49 plus 48 is 97. All over 4. Now you're probably thinking to yourself, that looks different from other answers we've had in the past here. I'm going to select some stuff and delete it real quick up here. Okay, that's not my best select and delete. Okay, here we go, a little bit better. Okay, let me write something up at the top here for you to show you what I'm saying. Now, when I go and I put these answers in, there's 2 answers. It's negative 7 plus the square root of 97, whatever that is, all divided by 4. And then there's a second answer, negative 7 minus the square root of 97, all of that divided by 4. Those are the 2 answers. Now, if you were doing this as a legit, taking an ACT or something like that, you definitely would want to answer these using this format. The full, complete, this fraction and everything, because this is the exactly right answer. In fact, sometimes this isn't even the most exact answer, because sometimes the root can be simplified, like root 97. Maybe you can divide something out and make it a little bit prettier. In this case, I can't, so these are actually the best answers I could have. However, Alex says round it and use commas on it or whatever. So, I mean, use commas between them and your silly rounded answers. Let's go to Desmos here. Desmos. So I got to write that in. Negative 7 plus the square root of 97. All of that divided by 4. By the way, if you want to know how I did all of that divided, by the way, I said by the way twice in the same sentence. I'm losing it, man. I'm losing it. Just so you know, whenever I make a square root, I type SQRT, and when you do that, it makes that. So if you want to save a little time and be a typing master if you're using a computer. And then if you select it all, I hit Control A for that, and then divide, it'll divide everything. Don't divide just some of it, divide everything by the number on the bottom, which became 4. So there's one of our answers. 0.71, that's it. That's to the nearest hundredth. Okay, now I need to do the same thing, but with the, instead of a plus, a minus. Okay, and that gives me negative 4.21. Always hope it's right. All right, good. It was right. So let's recap there. There's a lot. So the steps was I put it in standard form. I got it all on one side. I identified A, B, and C, and I just simply put them into the formula. And I made the formula a little pretty, and I got it to a point where I could just type it into the calculator and be done. Now, you don't always have to go through that much detail when you're typing it in, especially because we have access to a calculator and because Alex is okay with decimal numbers. Now, in reality, I would hope you would take it as far as I did. I'll do that on this one, but I will stop and show you where you can just get the answer and put it in. I'll show you how much work, I guess you have to do. So this one, got to have it all on one side, minus 2. So you get 9x squared minus 4x minus 2 equals 0. Okay, now it's all together. I'm going to put it in the formula, and the formula is, I'm just going to go for it though, negative b, so the opposite of b, that'd be 4, plus or minus the square root of b squared, that's negative 4 squared. Notice I'm putting it in parentheses, that's important. Minus 4, nope, let's make that 4 nice. 4 times a, in this case a is 9, times c, in this case c is negative 2. Here's my numbers there, I'm just underlining them to show you. All over 2 times a, which is, what was that, 9? There you go. Now, this is me just showing you, this is all you have to do. If you just put this and then you take it over to, Desmos, and you type that into Desmos. So on Desmos, I'm going to type 4 plus the square root of negative 4 squared minus 4 times 9 times negative 2 all over 2 times 18. Sorry, I'm thinking of what it'll equal, 2 times 9, which is 18. All right, there you go. See, I didn't even simplify it myself. I'm letting Desmos do it all for me, and that is one of the answers, 0.74. And then if I want to get the other one, I change that 4 plus the root into 4 minus that root. Negative 0.3, actually, because this is 298, and the 8 rounds it up, but it rounds up to 30. So I write 0.3. Oh, it didn't like that. 0.30, I guess. Why are you being a bum like that? Okay, 0.3, 0.30, they're the same thing. Like, who cares? All right, anyways, so there you go. All I'm saying is after you've moved it all to one side and put it in the formula, you can just put the formula into your calculator and get the 2 answers. Now, if it was you taking a real test, you would want to simplify this and get like the exact answers, which in reality is, let me do a little math in here, 16, 36, 72, 16 plus 72 is 88. This equals 88 all over 18. So that's a better answer. That's actually not even the best answer because 88 is divisible by 4, which leaves 22. So it would actually turn into 4 plus 2 root 22 over 18. But that's not even the best answer because the top numbers are divisible by 2. And you could actually turn this into 2 plus or minus root 22 all over 9. Like everything got divided by 2. That was outside of a root, by the way. So I think 2 plus root 22 over 9 would be the best way to answer it. And just to prove that I'm not crazy, I'm just going to show you this real quick. All over 9. Okay, notice that gives me the exact same answer I got when it was all jumbled, right? But if it was you taking a actual, high stakes test, I don't know. Maybe they don't want the decimals, they want the real thing. So I'm just showing you how to get the real thing, okay? Now, I had to do a little bit of fancy simplifying of the root, which is something we did a long time ago, and I'm not holding it to you right now. If you don't know how to do it, that's okay. I'm just saying it is an important skill, so something to work on, okay? All right, let's keep chugging along here. So we got 5x squared minus 9x equals negative 2. Okay, I can't have the negative 2 over here. It seems like on all these, I keep moving the plain number to the side with the other stuff. That's not always what's going to happen, but it's what's happening here. All right, so here, I'll be a little more thorough. Here's my A, my B, my C. So I go in, I start writing negative B. The opposite of B in this case is positive 9, plus or minus the square root of negative 9 squared minus 4ac. So 4 times 5 times 2 all gets divided by twice the a value. Now, if you're thinking to yourself, God, am I going to have to remember that for something in the future? I mean, helps to know throughout high school. I'm not going to lie to you. I'm not going to do it, but I recommend you YouTube search a video about it. They got little songs here and there. I'm not even gonna attempt to show you one because that's just cheesy. It ain't for me. But if it helps you remember it, do it. So we had 9 plus or minus, I'll just use the plus one first, the square root of negative 9 squared minus 4 times 5 times 2. I guess the 2 didn't need to be in a parenthesis, but whatever. All over 2 times a, 2 times 5. Okay, I think that's right there. So 1.54. And we'll go back and we'll change that to a minus. Get the minus version, 0.26. Because the 9 rounds that 5 up to a 6. Oh, goody. All right, let's keep going. I guess my point was I was trying to do the first two problems nice and slow and thoroughly and show you how to do these ones a little bit faster. 9x squared plus 2x equals 2. Minus 2 minus 2. 9x squared plus 2x minus 2 equals 0. So I moved the 2 to be a minus. And then I got x equals the opposite of b, so in this case, negative 2, plus or minus the square root of b squared, 2 squared. I put it in parentheses even though it wasn't negative, but that's okay. Minus 4 times 9 times negative 2. Don't forget the signs. My c is negative, so I got to make it negative. 2 times 9. And I get negative 2 plus or minus. Oh, I guess I didn't need to do this on paper. Okay, fine. I've already committed. Let's do it. 4, and then this will be plus 72, and this will be over 18. All right, and I'll simplify it one more just to be complete. Well, it's not really complete. I got to be honest with you. This is not actually the final answer because the square root of 76 can actually be simplified into, ooh, what can it be simplified? 6? No, 4 times 19. So 2 root 19. I don't know. Don't even mess with it. I went too far on this one. All right, so negative 2 plus the square root of, what did I get? 76 in there? I guess that saves me a little bit of typing by doing that. Go me, all over 18, 2 times 9. So this should be an answer. 0.37. And then we change this to negative 2 minus that stuff. Negative 0.60? I was going to say 59, but the 5 rounds it up, so I guess it's a 60. Oh boy. So here's the deal. As I said, this is not even the most simplified. This is the same problem I'm staying on, by the way, here. I'm going to use the top portion to simplify it one more time. If you were really doing this on a test and they really wanted the exact answer, not just a decimal thing like Alex tends to do, you would have to know to turn root 76 into 2 root 19. And if you're like, what, how do you even get into root 19? Well, 76 is 4 times 19, and 4 is 2 times 2. And because there's a pair of 2's, you're allowed to basically take the square root of 2. 2 times 2 is 4. The square root of 4 to the outside as a 2. And then the unsquare rootable part, the 19, stays on the inside. And then from here, since everything outside of the root is divisible by 2, we do that. So negative 2 turns into negative 1. 2 root 19 turns into 1 root 19. It's better just to write the root 19 without a 1. and the 18 turns into a 9. So the real legitimate best answer is this, and if you were watching the help video, no doubt you saw some problems where the answer was left like that. For our homework, we don't care if it's in a decimal form, which brings me to an important point on this last problem if you've been waiting and watching. On the very last problem here, I am just going to graph the problem because I'm sure if you are, a teenager, you're very likely to have just tried graphing this to see if it gives you the answer. And no doubt it gives you these two numbers that cross the x-axis. That's pretty much all the graph gives you. It doesn't give you anything else. It just gives you straight up and down lines. Negative 0.206. And wait, that's 1. Let's round it. Let's do what they want, right? 0.54. Will that be the answers? Why, yes, it will. Because everything we're doing is we're just trying to solve for what makes it true, aka the roots, aka that's what this is. And that's what we've been doing. So if you graph it, surprise, if you made it this far in the video, you can just graph it and get the answers. I'm sure people will figure that out anyways. Now, I do want to point this out. If I were to move this 1 over to the other side and not add the equal 0, it graphs like a parabola, which is how these quadratic things look, right? Now, this is a key factor. The how do you call it? You know how we do negative b over 2a kind of as part of the formula? Let me get paint open here. So you know how when we're writing the thing, if you'll notice, x equals negative b plus or minus b squared 4ac. Now this is for super smarties right here. So if you stuck around, you're a super smarty. I just want to point out this part. Negative b over 2a is part of the formula, sort of, right? It's some stuff you plug in. But we've seen that somewhere before. The vertex is always at, that's supposed to be an at sign, perfect at sign, negative b over 2a. That's the x value of it. And then you plug that in, you find out what the height is. So if I were just to do negative b over 2a on this, so the opposite of b is 3, and 2 times 9 is 8. Whoa, pause. 2 times 9 is 18. So 3 over 18 is basically 1/6. So see this vertex right here? See how it says 0.167? That's the decimal approximation of 1/6. So here's the thing. This formula is saying take the vertex and go to plus to the right this much and go to the left that much. Why is it saying take the vertex and go left some and right some, the same amount? Well, because if you go, let me get my Desmos here. If you go right a very particular amount, you hit this 0. And if you go left a very particular amount, you hit that 0. So that's what the quadratic formula is telling us. It's saying, hey, this thing creates the vertex, and this thing over here is called the discriminant. Well, the thing inside the root is called the discriminant. If you take the root of the discriminant, that will tell you how far to go left or right to get to the roots, and then it'll give you the two answers, essentially. So that's what the quadratic formula is doing. And it always works. Even if you could take the root of something, like let's say earlier I said you could do x squared minus 7x plus 12, and that was like 4 and 3, right? You could even plug that in the quadratic formula, and what would end up happening is the root part wouldn't be weird and irrational. It'd actually just come out nice, and then you would get two nice answers, 4 and 3, after all is said and done. So that's the quadratic formula for you. Okay, I made this one shorter than the previous week, thankfully, but it still seemed long to me for a 5-question homework. But then again, we are reaching the hardest stuff. Okay, if you stuck around this long, I appreciate that you watched it, and I will be looking forward to giving you the next 2 lessons, because I believe we are leaving Chapter 9. No more solving quadratic stuff. Spoiler alert, you're going to be doing that in more high school classes, so don't forget it. We're going to do a little bit of statistic stuff, which is actually not too bad. It's a very calculatory, so you'll get psyched. You're about to see a lot of instruction on how to use a calculator, especially the Desmos calculator. All right, thank you for watching, and I will see you guys on the next one. Bye.